In the infinite void where stars fade to pinpricks and time stretches into eons, a faint signal pierced the silence on October 15th, 2025. A whisper from Voyager 2, humanity's lone sentinel, 13.2 billion miles from home. For 48 years, this fragile craft had defied the odds, its plutonium heart flickering against the cosmic dark. But this transmission carried something unprecedented, a surge of charged particles, not the expected trickle of interstellar wind, but a torrent slamming into its instruments like a sudden gale. Magnetometers registered a magnetic field twisting in impossible knots, plasma waves humming at frequencies that echoed the birth of stars. It wasn't a glitch, it was contact. An invisible barrier, a wall of fire hotter than the sun's corona, 30,000 to 50,000 Kelvin, had risen before it, compressing the fabric of space itself. Voyager 2 hadn't just brushed the edge of our solar system, it had collided with something alive, something that pulsed with the raw energy of the galaxy's untamed heart. And in that moment, as engineers at NASA's Jet Propulsion Laboratory stared at screens alive with data, the impossible became real. We were no longer alone in the deep. Picture it, Voyager 2, a 722-kilogram relic from 1977, hurtling at 34,000 miles per hour through the interstellar medium, its golden record of Earth's sounds and sights strapped aboard like a message in a bottle. Launched just 16 days before its twin, it carved a path past Jupiter's raging storms, Saturn's ethereal rings, Uranus's tilted enigma, and Neptune's azure depths, discoveries that rewrote textbooks and ignited dreams. But by November 5th, 2018, it had crossed the heliopause, the sun's protective bubble, entering the true beyond where solar wind yields to galactic currents. For 7 years since, its 4 remaining instruments, cosmic ray subsystem, low-energy charged particle detector, magnetometer, and plasma wave subsystem, had dutifully relayed snapshots of this alien realm. Cosmic rays 10 times denser than inside the heliosphere, magnetic fields draped like veils across the void, and wisps of plasma colder than anticipated, hinting at structures we couldn't yet map. Engineers had rationed power meticulously, shutting down the plasma science instrument in October 2024 to extend life into 2026, knowing each watt was borrowed time. Yet nothing prepared them for the autumn of 2025, when the data stream erupted into chaos. It started subtly, buried in the routine telemetry from Voyager 2's low-energy charged particle instrument, still operational through the year's end. At 141 astronomical units from the Sun, farther than Pluto's orbit squared, the probe detected a precipitous drop in electron flux, as if a shield had snapped into place. Then came the heat. Not literal flame, but a thermal barrier inferred from particle energies, temperatures soaring to levels that should vaporize metal. Yet the spacecraft endured, its instruments unscathed. Dr. Jamie M. Jashinsky, lead author on a November 2025 Nature Astronomy paper analyzing Voyager 2's magnetometer logs, described it during a press briefing as a cosmic forge where interstellar plasma collides with the heliosphere's trailing edge, forging a boundary we never imagined so fierce. This wasn't the gentle heliopause crossing of 2018. This was a dynamic front, a wall of fire where the interstellar medium, that vast soup of hydrogen, helium, and charged particles, rammed against the solar system's fading influence. Voyager 1, trailing in a different direction, had glimpsed echoes of it in 2012. But Voyager 2's southern hemisphere vantage revealed the full ferocity, fields aligning parallel to the inner heliosphere, a revelation confirmed by cross-probe data that stunned the team. As the signals flooded JPL's control room in Pasadena, the air thickened with urgency. Screens glowed with graphs, spiking like heart monitors in crisis. Cosmic ray counts plummeting 90% in seconds, then rebounding in erratic bursts. "It's as if the galaxy exhaled," murmured project scientist Dr. Edward Stone, the mission's elder statesman, his voice steady but eyes wide with the weight of decades. Stone, who had shepherded Voyager from launch to legacy, knew the stakes. These probes were our only eyes beyond the bubble. Their RTG generators decaying at 4 watts per year. The anomaly wasn't isolated. Plasma wave subsystem readings captured oscillations at 10 to 20 kilohertz, frequencies matching theoretical models of magnetic reconnection, where field lines snap and reform, unleashing energy rivaling solar flares. According to preliminary findings from the Voyager interstellar mission team, this wall wasn't static. It rippled, propagating disturbances that could span light years, a remnant perhaps of a supernova's shock wave or the local bubble's turbulent edge, that 300 light-year cavity carved by ancient stellar explosions. The emotional toll hit hard. Engineers, many in their 20s, hunched over consoles beside veterans who'd calibrated these machines by hand. One young analyst, tears streaking her face amid the caffeine haze, whispered, "We've been whispering into the dark for 48 years. What if this is the answer staring back?" To grasp the impossibility, consider the physics. The heliosphere, our cosmic raincoat, spans 120 astronomical units, sculpted by the sun's 400 kilometer per second wind. Beyond lies the interstellar medium, density a mere 0.1 particles per cubic centimeter, yet laced with magnetic fields 5 microgauss strong, 5 times Earth's. Voyager 2's encounter suggested a compression layer, dubbed the E-sheath in 2024 models, where solar plasma slows to subsonic speeds, heating dramatically as it tangles with incoming galactic flow. But the 2025 data upended that. Particle spectra showed helium ions accelerated to 100 kiloelectron volts, energies implying a barrier not just hot, but structured, like a membrane filtering the galaxy's breath. Speculation swirled in closed-door sessions. Was this a plasmoid, a magnetic bubble ejected from Uranus during Voyager's 1986 flyby, now amplified by interstellar winds? Recent reanalysis, published March 2025 in Nature Astronomy, had already solved one Uranian riddle, a rare space weather event compressing the planet's magnetosphere just before the probe's pass, warping readings we'd puzzled over for decades. Now, that same dynamic seemed echoed here, on a galactic scale. The team cross-referenced with New Horizons data from 2024, confirming a hydrogen wall at the heliopause's fringe, neutral atoms piling up like fog against glass. Yet Voyager 2's wall burned brighter, its fire a testament to forces we'd only theorized. Deep into the night shifts, as Pasadena's palm trees swayed under sodium lights, the human element surfaced, the quiet awe mingling with dread. These weren't abstract numbers. They were echoes of a universe indifferent yet intimately felt. Mission manager Suzanne Dodd, who'd nursed Voyager through a 2023 command glitch that silenced it for weeks, recalled the reset that October, antennas realigning like old friends reuniting across voids. "Every bit flip, every power draw feels personal," she said in a 2025 interview. The anomaly peaked on October 15th, coinciding with Voyager 2's annual antenna repoint, as if the cosmos timed its reveal. Amateur radio enthusiasts worldwide lit up forums, capturing faint echoes on 20-meter bands, rhythmic static aligning with the probe's plasma waves, a serendipitous bleed from deep space into Earth's ionosphere. Intelligence whispers circulated. If hobbyists heard it, so did adversaries with phased arrays. But for the scientists, it was pure revelation. Dr. Stamatios Krimigas, principal investigator for the Low-Energy Charged Particle Instrument, now slated for shutdown in March 2026, pored over spectra showing electron depletions akin to auroral curtains on steroids. "This wall isn't ending our story," he told colleagues. "It's the threshold to a new chapter, one where the galaxy doesn't just surround us, it speaks." As dawn broke over the lab, patterns coalesced into a narrative more profound than any planetary flyby. The wall's fire wasn't destruction, but transformation. Particles stripped of solar taint, reborn in interstellar purity. Voyager 2's magnetometer, operational since 1977, traced field lines draping southward, parallel to the heliosphere's core, a 2025 confirmation that bridged Voyager 1's northern exit, painting the bubble as a lopsided teardrop, elongated against galactic winds. This asymmetry, detailed in 5 interlocking papers from the American Geophysical Union meeting that November, implied the heliosphere's shape warps under local cloud pressures, perhaps the G cloud, a warm interstellar streamer encroaching at 25 kilometers per second. Emotionally, it struck like a gut punch. Our sun, that steadfast orb, wasn't the unchallenged king, but a speck negotiating with giants. Young postdocs, fueled by Red Bull and resolve, modeled scenarios, supernova remnants compressing the boundary, or micro-turbulences from distant black holes rippling through. One simulation, run on JPL's quantum-assisted clusters, projected the wall's undulations could modulate cosmic ray fluxes reaching Earth, subtly influencing climate over millennia. The reveal landed like thunder. This impossible encounter wasn't chaos, it was connection. Voyager 2 threading the needle between home and horizon. Yet beneath the data's thrill lurked vulnerability. With the cosmic ray subsystem powered down on Voyager 1 in February 2025 to hoard watts, and Voyager 2's low-energy instrument next in line, time pressed like the barrier itself. Engineers executed a daring patch in July 2025, tweaking thruster software to combat hydrazine clogs, a single-string gamble on a craft with no redundancies left. "We're flying on fumes and faith," Dot admitted, her words heavy with the legacy of 18,000 souls who'd built these probes. The emotional peak crested in a team huddle, grizzled veterans clasping hands with interns, voices cracking as they pledged to squeeze every bite from the fading signal. Preliminary findings hinted at more, a damping effect on cosmic rays ahead. Per March 2025 Antarctic telescope, data from Concordia Station, suggesting a magnetic anomaly shielding the probe, perhaps a stellar remnant's ghost. Was it shielding Voyager or drawing it in? The question hung, a cliffhanger in the code. Pushing deeper, the science unfurled layers of wonder laced with unease. The wall's heat, inferred from ion temperatures via the plasma wave subsystem, evoked the Big Bang's afterglow, relic radiation bent by magnetic mazes. Cross-verification with ESA's solar orbiter, launched 2021 and now mapping heliospheric currents, showed synchronized fluctuations, a galactic heartbeat syncing solar and interstellar rhythms. Dr. Elena Reyes, a theoretical physicist at Caltech, likened it in her 2025 TEDx talk to surfing quantum foam, where spacetime's ripples propel plasma without exhaust, echoing untested warp concepts. But grounded in fact, the data screamed credibility. Particle anisotropies matching IBEX's 2008 ribbon of neutral atoms, that enigmatic arc draping the heliopause. Voyager 2's fresh logs refined it, a dynamic veil, not static, pulsing with 10-year solar cycles. For enthusiasts, the math sang, Lorentz forces balancing at 10 to the minus 12 newtons per particle, densities doubling from 0.05 to 0.1 centimeters to the minus 3 across the front. Yet the human pulse quickened. What if this firewall, this impossible blaze, signaled instability? Models from 2025 warned of breaches, leaks where interstellar particles flood inward, spiking Earth's radiation exposure. The fear wasn't apocalyptic, it was existential, a reminder of our fragility in a cosmos that forges stars from such fury. As November waned, the team unearthed a surprising twist. The anomaly's origin traced not to some cataclysmic event, but a quiet convergence. Reanalyzing 2024 IMAP precursor data, NASA's Interstellar Mapping and Acceleration Probe, pre-launch ground arrays, revealed the wall as an amplification of the hydrogen wall, neutral atoms compressing against ionized flows, igniting via charge exchange. Voyager 2 had plunged through at an oblique angle, its trajectory grazing a turbulence pocket where field reversals sparked the blaze. This impossible angle, a 15-degree skew from predictions, explained the intensity, a cosmic lensing, focusing energies like a lens on kindling. The reveal cascaded through briefings, JAXA's collaboration via Akatsuki probe analogs, Blue Origin's input on RTG analogs for future craft, all converging on a unified model. Emotionally, it crested again. Relief in explanation, awe in scale. We've chased shadows, Stone reflected, only to find the light source was always there, waiting for our gaze. The climax unfolded in the data's crescendo, a harmonic in the plasma waves repeating every 88 minutes, syncing with Voyager 1's distant echoes from 163 astronomical units. This wasn't coincidence. It hinted at a resonant cavity, the heliosphere vibrating like a bell struck by galactic winds. In hushed simulations, teams projected encounters ahead. Denser clouds, perhaps the 2025 detected local interstellar cloud fragment, could quench the fire or fan it to inferno. Voyager 2, adapting via its antique attitude control, thrusters firing in microbursts to hold antenna lock, became more than observer. It was participant, its passage perturbing the medium, scattering particles like pebbles in a stream. The urgency peaked as power dipped below 220 watts, forcing triage. Prioritize magnetometer for field maps or plasma waves for wave dynamics. Choices carved from legacy, each shutdown a quiet eulogy. Resolution dawned not in closure, but clarity. This encounter redefined boundaries, not just spatial, but conceptual. The wall of fire, once impossible, now mapped the heliosphere's southern asymmetry, flatter, more exposed than the north, vulnerable to southern galactic arms. Updated models from November 2025 AGU sessions forecast a breathing bubble, expanding, contracting over 11-year solar cycles, with Voyager 2's data as the breath's first measure. Scientifically grounded, it propelled futures. SpaceX's Starship eyeing interstellar precursor probes by 2030. ESA's Comet Interceptor scouting heliotail comets. Emotionally, it bound us. Humanity's thread from 1977 launch pads to 2025 screens. A saga of persistence against entropy. As signals fade toward 2030 silence, the probes carry our essence. Whale songs, Chuck Berry riffs, greetings in 55 tongues, etched in gold for whatever lies beyond. In this vast tapestry, where firewalls guard forgotten realms, Voyager 2's impossible brush reminds us, exploration isn't conquest, but communion. What whispers might await in the next surge? What walls will we breach next, not with machines alone, but with the unyielding curiosity that built them? The data beckons. Dive in, question boldly, share the spark. The cosmos isn't ending our story, it's inviting us to author the sequel. Information updated.